So if we want to solve an equation and we see parentheses involved, we're going to have to use that distributive property that we were talking about earlier in the week, where we can pass out with multiplication. Now, we have to be a little bit careful with how we distribute based on signs and numbers in front. So, for example, we have our very basic distributing, which means if we see something just like we were talking about earlier this week, right? If this comes up somewhere in the equation, maybe afterwards it says equals 20, okay, we will distribute just like we've been talking about distributing, where we will pass this 2 out to each piece, and when we pass it out, we use multiplication. Okay, so 2 times y gives us what? 2y. 2 times positive 3 gives us what?
6.
Positive 6. Right, so we could rewrite that as a 2y plus 6. Rarely do my students have issues with that. Okay, where I see the mistakes is when the parentheses fall amongst other stuff in the equation. So maybe we have an equation that says 4 minus 3 2y minus 8. Like maybe we're given this equation to solve. Right? I can easily ask my students, do you see parentheses? And my students say, yes. I say, okay, what do we do with parentheses? We distribute. But we need to make sure we're distributing the right number. So if we're looking at the number that's sitting directly in front of the parentheses here, what number do we see? Negative 3. Because this sign goes with the number. So when we are looking directly in front of the parentheses, I shouldn't draw right on top of the 2. Right? When we're looking directly in front of the parentheses, we have to take the sign with it. So we would say negative 3 times positive 2y. What does that give us? Negative 6y. Negative 3 times negative 8 gives us what? Positive 24. The rest of the stuff stays untouched and just comes straight down. And we'll talk more about solving it from there, but for right now. Okay, there's one more piece of distributing that my students miss. The parentheses can be on either side. Doesn't matter. As long as we see the parentheses, it's going to tell us to distribute. Okay, so we see parentheses. We know we need to distribute. We look directly in front of the parentheses. What sign do we see? Negative 1. So we don't see it, but it's there, right? So if we don't see a number, it's really a 1. And so we need to be distributing the negative 1. Okay, so negative 1 times 2y is negative 2y. Negative 1 times positive 4 is negative 4. Right, and we would solve or do whatever from there. Questions on that? Step 2 says that we are going to combine any like terms. So some of you in the ALEKS program have the topic to work on of just combining like terms by itself. Okay, combining like terms says that we're finding things that have the same type of label. An X can go with an X. A Y can go with a Y. Okay, but an X cannot go with a number that does not have an X. Those aren't like terms. So if we have something like this, okay, we would want to get things that look the same together. Which means these can go together because they both have the X. And I always tell my students, I know it's really dorky, and they're like, Mrs. McKinney, this is so dumb. Why are you telling me to do this? You can always replace a variable with your favorite fruit or vegetable. Yes?
My pencil just ran out of ink.
There's a bunch of pencils over here. Okay, so instead of saying 3x, you could replace this with apples, or bananas, or oranges, or broccoli. Right? So if you have 3 apples, and you want to add to it 2 apples, what would you get? 5 apples, right? The label doesn't change. Your apples don't turn into apples squared. They don't get cut differently. They are the same thing. So you're taking the numbers in front and adding them together and leaving the label the same. Now we see multiple signs up here, but the rule is the same as what we've been saying. We always use the sign in front. So if you struggle with your signs and you want to use a calculator, right? If you were to cover this up, you would just read this as 3 plus 2, and that's what you would put in your calculator. Same idea for the numbers that don't have variables. We can put those together as well. Again, just use your calculator if it helps you. I would rather you get it right than prove to me that you can add without a calculator. So if you needed to, right, you could put in your calculator -7 plus 5. What is -7 plus 5? -2. Now, you can have a lot of like terms to combine. You can have no like terms to combine. So be prepared for something that might say equals whatever. Hey, don't look at this and say, ooh, yep, those are fractions. I don't do fractions. Right? Because we all do fractions now because we have a calculator that we can use to help us. So if we want to combine like terms here, we have an X, an X, and an X. What number is in front of this X?
1.
-1. We're subtracting 1. So we would need to do 2.5x plus 1/2 x. What's 2.5 plus 1/2?
3.
3 minus 1.
2.
And then we would solve from there. a large fraction is a word that I'm kind of making up for anything that we talked about 2 days ago, where we had multiple items happening in the numerator. Right, large fraction because I have two separate things in the top. The numerator is the top. Okay, as opposed to this, not a large fraction because I only have one thing happening in the top. Doesn't really have another name. Right, but we said that those were technically in parentheses, which changed the order of how we did things. Okay, so we need to make sure we can consider that as a step. So if there is a large fraction, we're going to get that large fraction by itself. And then multiply by the denominator. What's the denominator?
Bottom.
The bottom, right? In that case, 7. Does this have a large fraction? Yes, right here. So I'm going to highlight the large fraction up here. But this large fraction isn't by itself, right? There's still something sitting over here with it. So we would need to move this adding 1, which we should know at this point we do by subtracting. Before we do anything with the denominator. Okay, so once we get it by itself, then we can multiply by that 2. This step right here is the